In this module, you will learn about the core components within the CommVault software architecture and how these components work together to form the CommVault data platform. We will also discuss some of the technical advantages that CommVault software delivers and discuss a high-level architecture consisting of the basic solution components. Let's begin by talking about CommCell architecture. As discussed in the last module, CommVault next-generation software is a flexible and powerful tool that can be leveraged to bring your customers' data management challenges under control. The software has evolved over many years to address customer requirements as they have emerged. One factor that has allowed CommVault to evolve the solution is that it was originally built on a solid foundation of design goals that have not wavered over the years. As customers embrace new cloud-based architectures, they are looking to control their workloads and datasets as they span both inside and outside of the data center. Many of the technologies CommVault software provides are dependent on the optimization of the movement and management of data. CommVault has always strived to find the most efficient ways to transport and manage data in a customer environment. From the early days of being pioneers in technologies such as source and target-side deduplication and OnePass, to technologies of today such as block-level backup and live VM replication and recovery. Another area of focus has been to minimize downtime and accelerate the time to recovery of data for business continuance and disaster recovery. One of the areas of discussion in this module will be around our distributed split-index architecture, which inherently provides organizations a faster path to recovery. Protecting and managing data is an important piece of the puzzle. But one of the areas where CommVault software drives operational efficiencies for our customers is through our capability to deliver both orchestration and automation that minimizes the infrastructure and efforts required for information management operations. CommVault next-generation software paves the way for organizations to activate true value from their data by transformation to a more open content platform used for analytics, federated search, and business process applications. As you will see shortly, CommVault software's architecture is built for resiliency and provides organizations the flexibility to create robust, protected environments independent of the location or hardware that it resides on and manages. Let's take a quick look at some of the core infrastructure components involved in a CommVault solution architecture. Each of these components will be covered in more detail momentarily. Although the multi-tiered data management architecture depicted here may not appear to be unique, you will shortly discover some key differences that set CommVault apart. Holistically, the components in a CommVault software environment constitute what is termed as a CommCell. Every CommCell starts with a COMMSERVE, which acts as the command and control center in the CommCell. Every CommVault environment has a COMMSERVE at its foundation. The CommCell console is the primary interface where CommVault administrative operations are performed. Please note that there are other web-based management interfaces available for specific power users, such as a VM administrator, for example, and these will be covered in a later module. The next components of note are media agents. Media agents are the servers that connect to back-end storage devices and handle the critical task of copying data from its source to that back-end target destination. CONTENTSTORE is a concept that combines our indexing and data packaging technologies with back-end storage targets to provide a global virtualized storage repository. Clients whose data is managed by CommVault typically leverage a software component known as Intelligent Data Agents, or IDAs. IDAs reside on the server or other computing device that provide the native file system and application awareness that allow for successful data management operations such as backups and restores. Another component we'll discuss is the search engine, which enables organizations to index the full contents of their data and provide end-user and/or compliance search capabilities across that data. Again, the collective components in a CommVault environment are known as a CommCell. The COMMSERVE acts as the command and control center of the CommCell and handles all requests for activity between Media Agent and IDATA Agent components. The CommServe serves 5 primary functions. It acts as the central point of administration of a CommCell. It handles the majority of administrative and operational tasks for a CommVault environment, such as configuration, security, licensing, policies, and scheduling. The Meta Database Catalog, housed in the CommServe, includes metadata about the nature and location of the data that is stored. It also acts as the central point of disaster recovery in an environment. The CommServe houses a database with configuration and media association, which in a disaster recovery scenario is the first item that needs to be recovered. Event orchestration. The CommServe also houses the centralized event and job managers that handle the orchestration of various operations within a CommCell. Reporting on the overall environment, including both the general health and welfare of an environment, as well as detailed reporting on the environment and data itself, is also handled by the CommServe. Finally, the CommServe handles all the management of security profiles and authentication processes. This is managed through local user security groups and/or through tight-knit integration with Active Directory. The CommServe acts as the command and control center for a CommCell and handles all activity that takes place between the various components in an environment. It contains a database which stores all of the information pertinent to a CommCell. An instance of Microsoft SQL Server is included with CommVault software and is leveraged to hold the CommServe metadata database, which tracks all activities in a CommCell. Updates and maintenance of this SQL instance are provided automatically via customer downloadable CommVault service packs and do not need to be maintained independently by the customer. The Job Manager element manages and monitors immediate or scheduled operations throughout the CommCell group. The Job Manager communicates with agents in order to initiate and monitor data protection and data recovery operations. The Job Manager communicates with media agents to monitor the resources necessary to complete these operations. The Scheduler allows users to schedule tasks so that these tasks can be initiated by the software. The CommServe also controls the Event Manager and Alert subsystems. The Event Manager monitors events occurring throughout the CommCell and reports them through the Event Viewer in the CommCell console. Users can obtain filtered data through the use of reports generated from the CommCell console. Users can also obtain information on non-active operations by viewing job history information. The CommServe server controls all user security within the CommCell component. It grants CommCell users permissions to perform actions based on their assigned roles. The CommServe software is responsible for storing a metadata SQL database which contains all the pertinent information on a CommCell. The software provides the ability to retrieve this data in the event of a disaster or system failure. And lastly, the CommServe houses the CommCell console, the user interface used to manage the CommCell. As mentioned, CommVault software includes an instance of Microsoft SQL, and the CommServe requires Windows Server 2008 or 2012. As with all CommVault components, always check the CommVault documentation website for full details of the most current supported operating systems. The Media Agent is a high-performance data mover server component in a CommVault environment. The Media Agent acts as the gateway between data streams from clients to the backend storage where managed data will reside. The Media Agents accept data from any intelligent data agent, and then transport that data to a broad range of storage devices, including disk, tape, or cloud storage. Media agents are also used during auxiliary copy jobs when data is copied from a source library to a destination library. With the exception of NDMP dumps, there is a basic rule that all data must travel through a media agent to reach its destination. The media agent maintains granular indexing information in its index cache, which includes detail on the jobs and objects that it has processed. Part of this maintenance is the periodic pruning of data from the index cache in order to maintain a reasonable footprint. The media agent is also typically the home for deduplication databases in environments. Another function that the media agent handles is that it interfaces with primary storage arrays for IntelliSnap snapshot management, which will be covered in more detail in later modules. The media agent is a highly scalable component in the COMMSERVE that can scale both up and out. In a scale-up scenario, a server itself can be sized and upgraded to handle appropriate loads and the amount of capacity managed. In a scale-out scenario, as an environment grows in terms of number of clients, physical locations, and/or capacity managed, additional media agents can be seamlessly added to the environment to accommodate the load. Media agents can be installed on most operating systems and platforms. For detailed information, please refer to the CommVault documentation website at documentation.commvault.com. In a CommVault world, the term client refers to any production resource that requires data protection or management. Such devices may include physical or virtual servers, network storage devices, or laptop and desktop computers. An IDATA agent is a software component which directly interacts with the file system or application requiring protection, and provides the common functionality of CommVault services and utilities for client systems. Each client server requiring protection will have at least one IDATA agent installed. The vast majority of operating systems and applications in the market are supported by CommVault. This includes the provision of application-aware and application-consistent data management capabilities to ensure that data is protected in a consistent state and is recoverable in a valid and usable format upon restore. Search engine nodes are an additional server component leveraged by the CommVault search engine and provide the full content search and indexing capabilities. This includes search for compliance purposes, as well as providing the capability for end users to search their own data at a very granular level. CommVault search capabilities allow organizations to index the contents of compatible data types and easily find specific objects based on a variety of parameters. Typically, the search node receives a copy of datasets subsequent to a backup or archive operation for processing. Search nodes contain a database with a full text index of any files that are capable of being indexed. Multiple search engine nodes can be combined to form a scalable search engine. In a search engine, at least one of the search nodes serves the dual function of both indexing and searching datasets. Due to the processing requirement of indexing operations, this server tends to be a workhorse. When an indexing search node's maximum object count is reached and the additional indexing search node is added, the original servers can be repurposed to search-only mode and can be virtualized to reduce cost. The last CommVault server component we will touch on is the web server and web console. By default, both of these server packages are installed as part of the COMMSERVE installation when IIS is enabled. The web server component is an application that provides a number of CommVault web application and search services such as end-user and compliance search. The web console component is a web-based application that allows end users to manage their data. The console is a self-service application that allows users to perform data management operations such as backup, restore, download, and so on. In addition, Web Console allows users to run reports, download software packages, and manage virtual machines, among other operations. Additional web servers and web consoles can be installed on separate hardware to provide greater flexibility and/or scalability in certain environments. The final CommVault software component we will touch on here is the Content Store. The Content Store is not a physical entity. It is a virtual repository that provides a complete view of all managed data, no matter where that data physically resides. The combination of CommVault software's robust indexing engine and capability to span multiple storage technologies create this virtual storage repository. The Content Store represents a common catalog and awareness of stored data regardless of where it resides, where it originated from, or how it got there. The Content Store is inherently scalable. CommVault software's capability to add additional storage as needs demand is not new, as scalability has always been a key differentiator for the solution. Storage can easily be added to house data as needs dictate. The CommVault next-generation software is not just about backed-up data, but encompasses live data in the enterprise as well. Access to configuration and data operations is provided to administrators, and for end users, access is provided for specific purposes, such as searching, viewing, and restoring their own protected or managed files. Content Store removes traditional data processing boundaries and extends our software's vast array of data services and management services directly to the end user. This is done through new and ever-expanding integration portals with commonly used end-user devices and applications. CommVault next-generation software allows organizations to leverage these core infrastructure components to handle a wide variety of information and data management functions, including data protection and recovery, archive of data for capacity optimization purposes, reporting and analytics, the management and induction of hardware-based snapshots into an overall data management strategy, data replication, search and analytics, automation, migration, deduplication, and disaster recovery. These functions may be applied across both physical and virtual environments for structured and unstructured data, both on-premise, in the cloud, and at the edge, spanning different server platforms, hypervisors, applications, and disparate storage platforms. With CommVault software, organizations are able to leverage shared infrastructure, consolidate and centralize the management of these functions, apply common processes across their environments, and maximize their storage efficiency by leveraging global deduplication. Effectively, this allows customers to minimize their learning curve associated with data management, designed for availability and disaster recovery in a holistic fashion, and minimize the amount of times that data requires processing. By doing so, the deployment of CommVault software can drive significant economic savings for organizations as well as dramatically increase the efficiency of their operations. Now let's move on to a discussion around CommVault software's unique indexing methodologies. A discussion on indexes may appear to be dry at first glance, but is actually very important to understanding how CommVault software provides resiliency and maximizes infrastructure efficiency in environments. There are 4 areas surrounding indexing that we will touch on. As was mentioned in the previous section, the COMMSERVE houses the COMMSERVE database, a relational database built on SQL that contains much of the critical metadata for a CommCell environment. Information such as scheduling, storage policies, activity, media management, reporting, security, and encryption is housed in the COMMSERVE database. It is important to note that the database only houses this lightweight metadata, which allows CommVault to maintain a small footprint for the database. Media agents are where the index cache and in many cases deduplication databases are stored. Recommendations for sizing index cache volumes are included on the CommVault documentation website, which should be referred to for all sizing recommendations. The index cache contains detailed job and object index information and characteristics. For example, exactly where a particular piece of data is being stored on a disk device or tape device within the content store. The deduplication database maintains hash records for deduplicated storage policies. The index cache is maintained locally by the media agents themselves and protected like the data itself inside the CommVault content store. So why does it matter? First of all, by distributing indexing across multiple layers, it minimizes the footprint capacity consumed by the indexes. Even in very large environments, the CommServe database maintains a minimal footprint. This allows for portability, and disaster recovery backups of the CommServe database are easily conducted to remote locations over a wide area network. A disaster recovery CommServe may be configured in a cluster arrangement or can be virtualized to minimize cost. As mentioned, the fact that the index information is also written to the content store contributes to the resiliency of a CommVault software environment. In the case of a media agent failure, a new media agent can be brought online after receiving information from the CommServe on where indexes have been stored. It can rebuild an index very easily and be brought back online. In a disaster recovery scenario, these capabilities, which are provided by CommVault Software's distributed indexing capabilities, result in a highly accelerated time to data recovery. Many alternative solutions in the market have monolithic databases that can grow to a very large footprints. In a disaster situation, the advantage of the smaller CommServe database becomes apparent. When a disaster transpires, the first step is to recover the CommServe database. Given its smaller footprint, the time required to restore this database is minimal. Once the database is restored, the CommServe will communicate with a media agent, and the media agent will initiate the restoration of data and servers. When directly compared to competitive solutions, customers see that the restoration process of their servers and the data on those servers is being initiated well before many competitive solutions have even finished restoring the database. This is a technical differentiator that has convinced customers many times and has won many proof-of-concept engagements for CommVault. The efficiency of data restoration and the time to recovery are critical aspects when choosing a data management solution, and CommVault software is head and shoulders above the pack in these regards. CommVault software is also renowned for its scalability. As the number of clients being managed in an environment or the datasets those clients generate increase to a threshold where the original number of media agents cannot accommodate a customer's established protection and recovery SLAs, it is a very simple process to scale out the environment by deploying additional media agents to accommodate the load. CommVault software also facilitates back-end scaling on the content store, or so-called scale-up. As an environment grows and more capacity is consumed, CommVault software alerts users and allows them to easily add storage. For example, if a disk library is nearing capacity, users can add additional mount paths to the disk library in order to seamlessly increase its capacity. These mount paths can potentially be from disparate storage arrays provided by disparate vendors. This aspect also helps to provide our customers with flexibility in terms of the storage platforms they leverage in their environment. We will finish this module by covering a couple of key concepts surrounding logical components in a CommVault environment. A critical concept to understand is CommVault software's storage policies. All data is not created equal, and it should not be treated as such. CommVault software is a policy-based architecture which allows customers to manage data to their business requirements. Although it may seem like an odd analogy, you may think of storage policies as a variety of milk cartons with expiration dates, different types of milk, and different recommendations on how that type of milk should be stored. Similarly, a storage policy can be thought of as a container that has different characteristics associated with it, which may be applied to the various clients and datasets in an environment. Essentially, a storage policy dictates the number of copies that should be made of a particular dataset, where that data should be stored, how long the retention of that data should be maintained, as well as a number of other storage parameters such as whether the data should be deduplicated or encrypted. The primary reason for using different storage policies is ease of data management. Data boundaries can be identified along the lines of data type, data source, and management requirement. Additionally, business, legal, and security requirements need to be considered when designing a durable storage policy schema. Taking the time to map out a storage plan will yield both more efficient and easier management for your data. Client computer groups are another CommVault software functionality worth examination. When planning for data management, it is useful to have predefined groups that share common characteristics. A client computer group is a logical grouping of clients in an environment that allows you to define options for an entire group of clients instead of defining those options for each client individually. Client computer groups are created for any number of reasons. Some of the most common reasons are grouping for the sake of security, reporting, automatic updates, geographical management, for example, to allow for different schedule policies to be applied depending on time zones. In this graphic, these clients have been segregated based on geography to allow for the staggering of data management operations across time zones in order to minimize impact on production environments. Client computer groups may also be created to accommodate business requirements. For example, different functional groups in an organization may have different service levels associated with the protection of their data. Client computer groups can easily accommodate scenarios such as this. As depicted here, a particular client may belong to multiple client computer groups. Finally, a smart client computer group uses a user-defined set of rules or wildcards. Based on these rules, existing or new client computers are automatically added to the smart client computer group. Clients are also automatically removed from the smart client computer group if they no longer meet the criteria defined in the rules. After you define a rule, you can preview the list of clients that will be included in the smart client computer group. While we are on the subject of clients, let's discuss the structure of a particular client in a CommVault environment. Earlier, we discussed the concept of a client as being an entity whose data requires management. With few exceptions, clients in an environment have an intelligent data agent loaded on them to provide CommVault software the awareness required to appropriately manage that particular server's data. The structure of the file system intelligent data agent is depicted here. The file system data agent is represented with a hierarchical organization. A dataset is a logical view of all protected or managed data that an IDA is responsible for. For example, in the case of a file system IDA, the dataset represents every drive, folder, and file on a particular server. A subclient is the smallest logical management container representing production data. There is a subclient configured by default with every IDA. The default subclient represents all of the data within a file system or application that is not otherwise defined within another subclient. This ensures that all the data on a client is protected or managed by default. Custom subclients may be created to allow particular drives, folders, files, file types, or UNC paths within a client to be explicitly defined. When designing an environment, subclients allow organizations to classify and define data at a more granular level. For sake of a simple example, a file server may contain a wide variety of data types, but the organization dictates that spreadsheets and other Office documents should be treated with more importance than MP3 files. A subclient that filters based on file type could be leveraged to ensure a higher SLA for the Office documents than the MP3 files. Another key concept we want to take a look at is how CommVault software handles the recovery of data in a single pass. To convey this process, let's take a look at a simple data protection operation. In this example, a media agent communicates with a client to determine the data that needs to be protected. A full backup of the data is then conducted. Thereafter, incremental backups are conducted. In this example, 4 incremental backups occur subsequent to the full. Let's assume that at this point in time, the client experiences a catastrophic failure and needs to be recovered. CommVault media agents index all data being written to disk or tape so the administrator can view all backup or archive data from any point in time, regardless of backup type. When the recovery process is initiated, CommVault software looks at the most current version of objects that will be present at last backup and identifies those objects. The media agent index is leveraged in order to gather the most recent copy of each file in the backup, and these files are utilized to conduct the system restore. CommVault software intelligently knows how to combine the latest full backup with incremental backups to present a point-in-time image to browse for recovery needs. This concept ties into CommVault software's synthetic full backup capabilities. Let's walk through a simple example with a single client to explain this functionality. To start, a media agent initiates a full backup operation from a client. After polling the client and understanding its data structure, the media agent transfers a processed copy of the client's data to some form of media in its full form factor. Thereafter, over a period of, let's say for example, the course of a week, incremental backups, which only write data that has been changed to the storage media, are conducted. But rather than repeating this cycle and putting unnecessary load on production clients, a synthetic full operation may be leveraged. The media agent is aware of the most current version of objects that are present on the storage media as of the last backup. When a synthetic full is initiated, these objects are first identified. The media agent then conducts an operation in which it compiles these objects into a new baseline, so to speak, dataset. This newly created set is coupled with the incremental data from either the job immediately before or after the synthetic full. This dataset is then used as a basis for subsequent backup operations, which in effect eliminates the need for recurring full backups. The key thing to remember is that after the initial full backup is conducted, apart from the activity generated with incremental backups, load on production clients is minimized since the synthetic full operation is conducted at the media agent. In the CommVault world, synthetic fulls are a very mature technology that have been leveraged in our software for many years. Conceptually, it is relevant not only for traditional backups, but also comes into play when we dive into our deduplication technologies in later modules. This concludes Module 2, the CommVault Architecture Overview. During this module, we discussed the core components within the CommVault software architecture and functions of the CommVault software server components. We also discussed some of the benefits that a unified software approach combined with the CommVault software indexing structure brings to the customer.